So a lot of people already this morning have talked about sort of integrating different data, and so I'm just going to briefly talk about a few examples and methodological developments that have moved us more into that direction, but yet there's still lots of challenges in this area. So first of all, I thought I'd just sort of start with a sort of few basics about sort of where we come from in terms of monitoring design and the different options. Again, we've heard of a lot of these already this morning. So options around sort of random sort of design. So by that I include sort of stratified, random sampling, cluster sampling, tessellation, stratification sampling, which we've heard about as well, which is nice to hear. So this is the sort of what a statistician would recommend to do. It's not always possible, but that's normally, if someone comes to you at the start, that's normally what you would recommend. Oops, don't give the game away. But then there's also sort of increasingly been sort of a move towards more sort of targeted monitoring. And by that, that's where you may have a specific question, a scientific rationale that you want monitoring for. So a really good example of this might be agri-environment scheme monitoring. But it's not random, it's targeted, but you want to go where you can answer this question for. So unlike the first, which may be unbiased, the stats is nice and easy, the targeted, there is a bias, but you have sort of designed it in, if you like. And the last, which is sort of growing in popularity, is more opportunistic monitoring as well. Again, we've heard about that from Anna with a lot of the JNCC from schemes. The challenge there is that the bias is unknown. Now, when I talk about bias here, it's sometimes slightly annoying because the data itself is not biased. The bias comes in terms of what you assume that data represents, what you want it to be representative of. So opportunistic data is not biased, but it might be biased in terms of what you want it to represent. So I just thought I'd make that explanation. And the challenge here is that as you go down these, there's an increasing sort of complexity of analysis. So I have to spend more and more time analysing the data as you go further down, which is another reason why the statistician always recommends the top thing. The analysis is easy if you do the top thing. Okay, but so there are challenges there. But again, as we've heard already, it's not just about traditional sort of survey, which that fits into. There's a growing sort of this increasing technology means we've got more and more data from sensors, Earth observation, citizen science data from phone applications, and so we've got this sort of data sort of deluge, if you like. We're sort of growing in lots and lots of data. And so the challenge is, or if you like, what we'd like to do, is to integrate all these different data sources together. Again, we've heard about this already. And it's worth just thinking about why would we want to do this. It's worth just taking a little bit of a step back as to why we want to do this. One might be for consistency, rather than having multiple schemes that are giving you different answers of the same thing. So how is sort of plant species richness changing? We don't want 4 different answers depending on the scheme that you go to. So we want some sort of consistency. Another might be sort of increased resolution. If we can bring together, integrate different data sets together, can we sort of increase our spatial or temporal resolution? And other advantages around sort of increased sort of precision or sort of increase our power to detect sort of effects, so effects of the climate. So these are all sort of good reasons why we might want to integrate data. It's worth saying at this moment that there's no such thing as a free lunch. So if we don't do any monitoring at a high spatial resolution, we can't suddenly derive that in some sort of fancy way. So, sorry, this hasn't come out particularly well. So, different methodologies for combining data. So the simplest and what you might sort of naively do is to sort of pool your data. By that, throw it all into a single spreadsheet and just analyse it as if it was all the same. Now that, I'd put that at the top as if that's the easiest thing. And actually the biggest challenge with all of this is that first step of getting the data into a consistent format whereby you can integrate it. That's often the biggest challenge. So that's the simplest thing to do, is just to sort of pool it. There are problems with that, which I'll talk about in a second. But the other way is to assume that there's some sort of truth out there. So if we're talking about sort of species distribution, the species are somewhere. There's some truth And what you assume is the different sort of monitoring schemes, or the different ways in which that is being monitored, are different views on that same truth. So the pooling bit sort of assumes that the observation model, if you like, that view, that lens on the truth, is the same. That's the sort of hidden assumption you're making there. Whereas, when you account for that, you're saying, we acknowledge that there's these different views on the data. How might that sort of look into a lens on the truth? And there's a method for doing this. I'm not going to go into any detail. I've not provided any equations. I could have done. I was a bit sad that I didn't do, but I thought it was best not to. So there are key differences between the different data sources. So those observation processes that I talked about, there's different reasons why we might have these different observation processes. It might be scientific rationale for why the scheme's there in the first place, different scale, they're representative of different aspects of the environment. Different protocols is probably one of the biggest differences here. So are the schemes all recording cover data, for example, if they're going out doing vegetation quadrats, or is it just presence, absence? What scale is that at? And things are, I put uncertainty, I suppose, by that. I was thinking about sort of observer error or issues such as that, so the sort of quality of the information, if you like. So all these things differ across the scheme. Now, a big challenge, because I was asked to talk about challenges, is what's known as the change of support problem. This is a bit of a stats term, so I'll skim over it as much as I can. But essentially, if you take this top left figure here, we've got some sort of truth here, and it's been observed in two different ways. One is sort of a point way of observing it, and the other is at an aggregated spatial level. Now, combining these two things, you've got to take account of the fact that the aggregation and the point aren't the same sort of thing, and you've got to sort of account for that difference, that change of spatial support, if you like. And that's what's challenging sort of statistically. Okay, so now I'll just run through some examples of work that we've done in this sort of area. So this is the first example where we're interested in sort of mapping soil carbon across England and Wales. This was work we've recently done with DEFRA. And the idea here was to combine, so there's three sort of huge national data sets here: Countryside Survey, the BGS GBase Survey, and Cranfield's National Soils Inventory data. So these were all sort of over the sort of 2000 to 2008 sort of period. And you can see from the map of the locations of where they are, there's different extents here, they sort of follow different protocols. So there's lots of challenges, and they've each reported on soil carbon change and come up with different answers. So again, what we want is a sort of consistent sort of answer here. And although the protocols differ, you'll see from the thing in the bottom left there, the idea is you can sort of see that they're all measuring the same endpoint, LOI, this loss on ignition, and the cumulative distributions look similar, so it's that what they're measuring is similar-ish. And bypassing all details, but I'm very happy to talk about it, we were able to sort of produce this sort of, bringing that data together has allowed us to produce this sort of national scale across England and Wales map of changing soil carbon from the sort of 1970s up to the sort of 2000s sort of period with uncertainty attached to that. So we've gone from sort of national schemes, some of which have been reported at a national level, to sort of high resolution maps where you can pull out some local areas and those vulnerable areas as well. Similarly, we've done something on looking at habitat extent by combining sort of field survey data and remote sensing data. So this is Countryside Survey Field Survey and land cover maps, that's the remote sensing. And here, there's this assumption that there is some truth that these two are sort of observations of that truth, and combining them in a way that you can produce this product. So that has enabled us to produce consistent estimates of habitat extent rather than a land cover map based estimate of how much heathland there is in GB versus a Countryside Survey Field Survey sort of upscale estimate. So again, this one's around sort of the consistency. And some work we're These are very spatial examples, but some work we're looking at at the moment is combining data from the Environmental Change Network, Natural England's Long-Term Monitoring Network, the National Plant Monitoring Scheme and Countryside Survey to look at trends in vegetation indices over time and drivers of that change. So again, the dotted line is kind of this sort of truth, if you like, where we've got different representations of that from the different schemes. So, sort of finishing up, this is, I suppose, where we're going in terms of monitoring and modelling sort of work, which is, this is, I suppose, is traditionally how we've looked at things, which is to sort of take a data set, go through some sort of modelling exercise and produce some data product like a map or something. And building on that, we're trying to look at bringing in auxiliary information, such as things like altitude and geology that can really increase the sort of potential for those products. But moving forward, we want to sort of include other data sources and even model output as well. I think this is another key aspect of how you can bring that into this sort of framework. And then something else I'm particularly interested in is how your results then feed back into your monitoring or your modelling to sort of improve that and sort of to make things as efficient as possible whilst retaining that ability to produce sort of unbiased representative estimates. So to summarise, and yes, apologies there's no detail, but yeah, please do talk to me about this equation. There's numerous methods for sort of combining data from different sources now. There are still sort of challenges statistically around that. And I think, as I've said, one of the biggest challenges actually is around just bringing the data together in the first place. And you know, with some of the work we've done, a lot of colleagues have spent a lot of time just on that, what is seemingly a sort of trivial step, but it's very time consuming. So there's changes there that you think could be made to improve that. The challenges around knowing these different observation processes. If you don't know them, then how you bring that data together is challenging. And so it's important, really important to consider if it's sensible to combine data. You might sit there and think, oh right, we've got a method to do this, great, let's throw everything in there. And actually, if it's not sensible to do that, so if they're not measuring the same thing, if we can't assume that the relationships between sort of potential drivers are the same, then throwing these things all in together can actually be worse than analysing them individually. Because if you've got opposing effects in the two different schemes, when you bring them together, they cancel each other out and you find nothing. So it's really important to think these things through quite clearly. I think we're making progress on the statistical methodological side, but there's still a lot of challenges that we face. And I'll finish there.